Welcome back. Recall, a system of linear equations may have exactly one solution or no solutions or infinitely many solutions. You see, zero solutions, one solution or infinitely many solutions. The above example, that is the example we just did, resulted in exactly one solution. Here is a case where you have no solutions. Suppose you have a row echelon form. Notice you have one. This is actually reduced row echelon form, not just row echelon, because you have zeros above as well as beneath. But the last row does not have a 1. So I cannot make these elements zeros. I don't have a 1. What does this mean? This means the last row, notice the last row, 0x plus 0y plus 0z plus 0s equals 2/5. Everybody is 0 on the left, 2/5 on the right. That is a contradiction. Okay. So equation 4 is a contradiction. 0 equals 2 over 5 cannot happen. So the system does not have any solutions. On the other hand, here is a case where you have infinitely many solutions. So before I move on, let me highlight. If your row echelon form, the coefficients are all 0 in some row and the result is non-zero, then you have no solutions. But you have zeros here and 0 here, you may have a solution depending on what happens before that. All right? Okay. Now here we go. This is a row echelon form that is not 0. So this is not a reduced row echelon form. You see, but you have one more column which cannot be played with. That is, there is no row beneath it to resolve it. What does that mean? I have 3 equations and I have 4 unknowns, 4 variables, more variables than equations. All right, let's see what happens in this case. Write the augmented matrix in the form of equations. It says x plus 0y plus 1z plus 2s is negative 2/3. That's fine. Second equations, 0x, 1y, 0z, 3s equals 5 over 6. Fine. Third equation, 0x, 0y, 1z plus 2s equals half. So you see, we have not hit any contradiction. There is nothing that says 0 equals 3 or something like that. Well, we can work with the system. Always start from the last one. Z plus 2s equals half. That is, z equals negative 2s plus 1. Work backward, which tells us y plus 3s equals 5/6, which means y equals negative 3s plus 5/6. Let's go back. Y plus 3s equals 5/6. Now work backward some more. X plus 2s equals negative 2/3. X is negative 2s plus minus 2/3. Fine. That means if s is any real or complex number, we can find x, we can find y, and we can find z. Notice, s can be any real or complex number and you are able to find x, y, z. That is, the system has infinitely many solutions, one for each chosen value of s. Which brings us to an important remark. If a row of the augmented matrix is transformed to all zeros except the last entry, then there is no solution. Okay? This is what I told you about. If I have all zeros here and no 0 here, then you have no solution. That's remark 1. Remark 2. In both Gaussian elimination and Gauss-Jordan reduction, we may only use row operations. Do not use column operations. Okay. Remark 3. While all our examples have had real number coefficients, the methods used so far can be used with complex coefficients as well. The same methods work if you have equations involving complex numbers. Now let's play with homogeneous systems. What is homogeneous system? Right hand side is 0, B is 0. So suppose the row echelon form of the homogeneous system looks like this. This is row echelon. Notice that's not 0. These guys are not 0. So this is indeed a row echelon form. Well, how do we solve for them? You notice here right away S equals 0. If S is 0, can I find Y? Y also has to be 0. Sorry, this is Z. Y also has to be 0. X also has to be 0. This is the only solution. Check for yourself. Check for yourself if you don't believe me. Work backwards. S equals 0. Solve for Z. You will get that to be 0. Then work backward. Y equals 0. Then work backward. Check this part. Don't believe me. Check this part. Now here is another example, homogeneous system. That is also row echelon because this is not 0. What happens here? You have infinitely many solutions. S can be any real number and you get Z equals negative 2S, Y equals negative 3X, 3S, that is a typo, it should be an S, Y equals negative 3S, X equals negative Z minus 2S, Z in turn is negative 2S, so X has to be 0. Okay? Check what I'm saying here, both these. If it's not clear, ask me in class. A homogeneous system of m linear equations in n unknowns always has a non-trivial solution. Non-trivial meaning non-zero solution. So homogeneous means right hand side is 0. You have non-trivial solution if m is less than n. M is number of equations, n is number of variables. So if number of variables or the number of unknowns are more than number of equations, you are guaranteed a solution, a non-trivial solution. So let's go back to the two examples. Look at that. Number of variables 1, 2, 3, 4. Number of rows 1, 2, 3. More variables, you are guaranteed a non-trivial solution. Okay? Non-trivial infinitely. Because this is homogeneous, now you are non-trivial, you end up having infinitely many solutions. Whereas here, number of variables 1, 2, 3, 4. 1, 2, 3, 4. They are equal. I have only the trivial solution. Everybody equals 0 is the only solution. Okay. So, proof. When the number of rows or the number of equations is less than number of variables, the row echelon form of the augmented matrix is rectangular, fewer rows than columns, excluding the B column, okay? You have fewer rows than columns. Ignore any row that is entirely 0. You can push it to the bottom, any row that is entirely 0. Now the last row has a 1 and then follows by something we don't know, 0 or non-zero. It should look something like this. The last row looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, the variables after location I, suppose this is location I, all these variables can be any real or complex number, resulting in infinitely many solutions. That's the story. That's all. Now, what is the relationship between non-homogeneous linear system and homogeneous linear system? This is interesting. Let Ax equals b, where b is not 0, be consistent. Consistent means has solutions. It is a non-homogeneous system because the right-hand side is not 0. If xp is a particular solution, so what that means is, say you have by some fluke found a solution to the system, not by hard work or anything, or even by hard work, I don't know. Pretend you have guessed a solution to this system. If xh is a solution to the associated homogeneous system. So those of you who have taken differential equations will recognize this. If not, here is what I'm saying. Replace b by 0, find a solution. Find a solution of the homogeneous, and say somebody gave you one solution of Ax equals b where b is not 0. Then the particular solution plus the homogeneous solution is also a solution of the one without 0. Well, moreover, every solution to the non-homogeneous system may be written in the form of, so every solution can be written as particular plus homogeneous. Okay. Well, suppose xp, particular solution, is a solution. What does that mean? When I replace x by xp, I get the answer. Suppose xh is a solution of the homogeneous one. That is, I replace x by xh, I have an answer. Well, what's wrong with it? A times xp plus xh is, by distribution, axp, axh. axp solved the result with a b at the end. Axh solved with 0 at the end. So put together, they solve b again. That is, particular plus homogeneous solves the system with b at the end. That's the claim. It's the solution. It's a solution of the non-homogeneous system. Conversely, suppose x is any solution, then x minus xp, remember xp was something given to you. Consider x minus xp. A times x minus xp, ax minus xp. Well, x solved with b at the end. xp also solved b at the end. So the difference is 0. So the difference solves 0 at the end. That is, x minus xp is a solution of the homogeneous system. Therefore, call x minus xp xh, that is a solution of the homogeneous system. In other words, x itself may be written as xp plus xh. So what we are saying, one way or the reverse, that any solution with b at the end can be written as a particular solution plus a homogeneous solution. Okay. So that completes section 2-2. Here are homework problems from this section: 1, 3, 5, 7, 9, 11, 15, 17, 21. Okay. See you in the next video.